you should know that I've got you on my mind, your secret admirer. I've been watching you at night. I think of you. I want to be.
Woo! Cat dancing. Mr. Durkis back at it again with the kitty cats. Alright, let's talk some math. You've done so much this year, and now we're going to get into some important algebra material. So we're going to start graphing lines, and the first part of this is plotting points on a coordinate plane. We're going to get started. Before I do though, math morning! Alright, let's begin. What we have here is a Cartesian plane. This idea was created by a famous mathematician called Descartes, hence the name Cartesian. We need to really master this before we get into graphing, how to put points on here, so I'm going to start with some vocabulary. This line right here, the horizontal axis, we call this the x-axis. So it's a line that goes from left to right in the middle of this plane. We call that the x-axis. The other big line right in the middle, going vertically up and down, we call that one the y-axis. So we have x-axis, y-axis. Another important part of this graph is the middle right here. This point is called the origin. This is where everything originates from. It's the original point, hence origin. So we start in the middle, and this point, if I give it coordinates, is 0, 0. So speaking of these coordinates, that's another word. So we have coordinate. Sometimes this might be called a coordinate plane. Common way to name coordinates. Every time we do, we have an x, a comma, and then a y. So coordinates will always be in the order of x, then y. So what does this mean? Let me give you a real example. If I choose A, that will be my first point. And let's say it's 2, 3. So how this works, I start in the origin, right in the middle, and the first number is the x value. So it says 2, so that tells me to go 2 to the right. And the next value is 3, which is the y, and that tells me to go 3 up. So I go 2 to the right, and why am I going to the right and not the left? It's because this is positive 2. If it was negative 2, I'd go to the left. And the reason I'm going up is because it's positive 3. If I was going down, it would be negative 3. So, okay, let me start for real this time. I go to the origin, I go 2 to the right, 1, 2, and then I go 3 up. 1, 2, 3. I put a point right there. That will be point A. Perfect. Let me try another point. Let me call this one B. What if I do negative 5, 4? So again, I started the origin. This time I'm going, this says negative 5, so I have to go 5 to the left and then 4 up. So let's try that. Start in the middle, go 5 to the left. 1, 2, 3, 4, 5, and now I go 4 up. 1, 2, 3, 4. Bam, right there, and that was point B. Let me just do a couple more. C, let me call this one negative 2, negative 3. So again, I start at the origin. The negative 2 tells me the x, so I go 2 to the left. 1, 2, and the y tells me to go down. Negative 3. All right. 1, 2, 3. Bam, right there. That's point C. Point D. Let me see here. How about I go 6, negative 5. So I start in the middle. The 6 is positive, so I go 6 to the right. 1, 2, 3, 4, 5, 6. And the negative 5 tells me to go down 5. 1, 2, 3, 4, 5. Bam, right there. That's point D. I'll do one more. I'll call this one E. How about 0, 5? Well, 0, that's a little tricky, right? That's for the x. I have to go 0 in the left or right. Well, if it's 0, you don't move. So you just stay in the middle. And then the 5 tells you to go up 5. 1, 2, 3, 4, 5. Bam, there I am. That's point E. All right. If you notice, I kind of went around this Cartesian plane when I put these points. And it's broken into 4 different sections. We have names for those sections. They're called quadrants, as I wrote that down here. The first quadrant, oh, hang on, let me change. So the first quadrant is going to be the top right section. So this over here is quadrant 1, and we name them using Roman numerals. The second quadrant is the top left. That's over here. The third one is the bottom left. That's over there. And the fourth quadrant is the bottom right, right there. So we have first quadrant, second, third, fourth. So where were my points? So point A, that was in the first quadrant. Point B, that was in the second quadrant. Point C, that was in the third quadrant. Point D was in the fourth quadrant. Now what about point E? That one was right here. It looks like it's between the first and the second. If it's on the X or Y axis, we just say what axis it's on. So point E, that was on the Y axis. All right, so these are important vocabulary items and steps that we need to do when we start graphing. We're going to move on to the next part and put these ideas into action. So now we're going to try to get some points from this line. If I look at this line, the first one that jumps out to me is this point right here. So it looks like it's on the y-axis, and I have to go up 1, 2, 3, 4. So this point right there, that is 0, 4. Let's see, and it looks like, okay, this point right there, it's at a place where 2 of these grid lines intersect. It's not like in the middle of a blank space, but it's where 2 grid lines intersect. That point right there, so how can I get over there? If I start in the middle, I count 2 to the left, 1, 2, and I have to go up 1, 2, 3, 4, 5, 6, 7. So I went 2 to the left, so that's -2, and I went up 7. All right, let's see. There's another good one right there. There's another one right there. So this point, I have to go 2 to the right and 1 up. So that would be 2, 1. This point over here, I went 1, 2, 3, 4 to the right and 2 down. So 4 to the right is +4, 2 down is -2. And there's a infinite number of points on this line, but sometimes, right, you might have to estimate. Like if I was right here, it looks like it's to the left 1, but I don't know, is it like a half, or is it a little less, a little more? I don't know for sure. So if I want to name points on the line, I'm just going to try to use the ones that are very clearly obvious. Another way that I could write all these points down, and you're going to see it a lot, is just writing a table. So if I have an X and a Y, put that on the top. This point right here, when X is 0, Y is 4. The next one, when X is -2, Y is 7. And then we have 2 and 1. And then 4 and -2. So either of these sections represent these points on a graph. More often than not, you're going to see a table. A table. All right, so let's move on and apply these a little bit more. So now we're going to take a verbal phrase and translate it into a graph, into a line on a Cartesian plane. You see over here where it says equation, y equals, this is where we're going to write the equation. The initial value, that's the starting amount, and the rate of change, that's how much the equation is going to change for each time period. So let's see what it says. Sarah has 2 baseball cards. Each day she collects 3 more cards. So she has 2 baseball cards right now. That's her initial value. She has 2. Okay, so 2 baseball cards. each day she collects 3 more cards. So every day that goes by, she gets 3 more cards. That's the rate of change. So the rate of change is 3, and that's going to be 3 cards per day. So every day she gets 3 more cards. The initial value is 2. I'm going to write cards there too. So if I was going to write an equation for this, I can write down my initial value, cards. So she starts with 2 cards, right? And then every day she gets 3 more cards. So I can write, more is plus. She gets 3 more. How many days, right? That could change. It could be 10 days, it could be 100, it could be 1. If I don't know how many, I just put an X. So this is an equation for the information that we got from these verbal sentences. Over here is a table. All right, so I can fill these out. Well, let's see, can I label them? So the X, that is the horizontal axis, and that's going to be time. So as time goes on, Sarah gets more cards. What is the unit for that? Well, it says she collects 3 more cards, and that's going to be every day, right? Each day right there. So the time is going, or the unit will be day. Now the y-axis, or this the right side over here, that's going to be cards, right? That's how many cards she has. The units, right? So she starts with 2 and then she gets 3 more every day. That's going to be just the number of cards that she has. What I can do is fill out this table now. So before her day even starts, she already has 2 cards. That's her initial value. So I can put a 2 right there. Then every day after that, she gets 3 more. So the next day is 5, and then after that is 8, and then after that is 11. If you notice, those are increasing by the same amount. So she started with 2, and the next day she got 3 more. And then after that, she got 3 more. After that, she got 3 more as well. All right. If we were going to put this on the graph, I know this is my x-axis, the horizontal, and the y is vertical. On this table over here, the left side is normally the x, and the right side is the y. So I can plot these points over there. But what if I wanted to, figure out how many cards she had after 20 days? I know this is not in your table, but is that even possible? Well, I could continue this trend and just do +3, +3, +3. It looks like 17 more times. But I can also use this equation that I have. So if I wanted to find out, I can write y equals 2 plus 3x. I just said that the x is the days, and I want to do 20 days. So I can put the 20 in for the x. So I can write y equals 2 plus 3 instead of x. I write 20. Now I need to simplify. Y equals, I need to multiply before I add. So 3 times 20 is 60. And then I have the 2 over there. And lastly, I just add y equals 62. So if I had 20 days, Sarah would end up with 62 cards. 62. Perfect. So you can really get the answer for any amount of days. Now if I want to graph this, I can take these numbers over here. These are all points. So 0, 2, right? That is 0, 2. So I start in the origin. I don't go left or right because it's a 0. And then I go up 2. 1, 2. Right there. The next point would be 1, 5. Because x is 1, y is 5. So I go 1 to the right, up 5. 1, 2, 3, 4, 5. The next point, 2, 8. So I go to the right 2, 1, 2, and up 8. 1, 2, 3, 4, 5, 6, 7, 8. Now you want to connect these dots in a straight line with a ruler. Bam! Magic. I just made that line. So you should connect all the dots. The line goes forever in both directions, and that is how you graph an equation that you get from some sentences. Awesome work. This question says, is the point 5, 8 a solution to y equals negative 2x plus 3? I know this is not written in your packet, but you need to write it down. So 5, 8, if you remember from the beginning, the first number is always an x, and the second number is a y. So is this xy, 5, 8, a solution to this equation? What you can do, you just plug in the numbers and solve it. So when I see an x, I'm going to put in a 5. When I see a y, I'll put in an 8. So it says y, instead of y, I'll write 8 equals negative 2. Instead of x, I write 5. And then plus 3. Now I just need to simplify this and see if it actually is equal. So the left side will stay the same. Order of operations, this is multiply, that's add. I multiply first. Negative 2 plus or times 5 equals negative 10. Then I have plus 3. Now I have 8 equals negative 10 plus 3. That's negative 7. So are these the same? No, they're not. So this is not a solution. It makes me sad. So no, not a solution. Another way you can do this is by graphing this line and then seeing if the point is actually on the line. So I have a table over here. This is my equation. I want to find some y values for my x values. So it says x equals 0. So I'm going to put in 0 for x and find out what y equals. Alright, so when x equals 0, I'm going to say y equals negative 2. Instead of x, I put in 0, and then I do plus 3. When I simplify, negative 2 times 0, that's 0 plus 3. So that means y is 3. So when x is 0, that means y equals 3. So I can put 3 right there. Let me do another one for you. I'm going to do this one over here. So x equals 1. So when x equals 1, I'm going to say y equals negative 2 times 1 plus 3. I don't want to get these mixed up. Y equals, I need to multiply before I add. Negative 2 times 1 is negative 2. And then I have plus 3. Negative 2 plus 3 is negative 1. So when x equals 1, that means y equals, oh, hang on. Did I say negative 1? No! Negative 2 plus 3. Come on, Mr. Darkest. You're better than this. This should be a positive 1. No, negative 1. It should be a positive 1. I need to check myself sometimes. So x equals 1, y equals 1. So I'll put that right there. You might notice that the initial value of this is 3, right? We start at 3. And then every time I increase x, it goes down by 2, this negative 2. So you can keep plugging these in and solving, or I know that every time this is going to go down by 2. So 3 minus 2 is 1, right? 1 minus 2 is negative 1. Negative 1 minus 2 is negative 3. Negative 3 minus 2 is negative 5. Negative 5 minus 2 is negative 7. So every y value decreases by 2. Now I can put this line, these points on the graph. 0, 3. So I start at the origin, and that's right there. And I have to go up 3. 1, 2, 3. The next point is 1, 1. So I go 1 to the right, and I go up 1. The next point is 2, 1, 2, negative 1. That's right there. The next point is 3, 1, 2, 3, negative 3. 1, 2, 3. And you'll see, right, these are all making, if I connect these, they'll be a straight line. If you try to plot a point and you get it like up in the top right, then you should probably double check your work. Next one, 4, negative 5. 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4, negative 5. That one still looks good. 5, negative 7. 1, 2, 3, 4, 5. -1, -2, -3, -4, -5, -6, -7. So there we are. Now on your paper you can connect them with a ruler. I'm going to do some fancy magic and connect it with a line. There you go. So all your points should be connected with one line. Now if you look, this says, is the point 5, 8 a solution to this equation? Well, let me take out my pen again. 5, 8, where's that point? I start the origin, I go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. That point's right here. That point is 5, 8. So is this on that line? No, it's not, right? It's not even close. So that means it's not a solution. If I gave you a different problem and it was right on this line, then it would be a solution. Last question from me. Can you fill in this table? So I have a table over here. I know the x's. I don't know the y's. They gave me this graph. What can I do? So it says x is -3. What's y? So if I start the origin, it said x is -3. So I have to go -1, -2, -3. What's y? Well, if I go down, it crosses right there. So -1, -2, -3, -4. So this point, -3, -4 is on this line. Let me just double check. -1, -2, -3, -1, -2, -3, -4. I got it. The next one, x is -2, what's y? So I start the origin again, -1, -2. Where's the y? Well, I have to go down to -1, -2. So this point is -2, -2. When x is -1, y, I don't have to go up or down, so that means y equals 0. Then when x is 0, I go up, it crosses right there, that means y equals 2. When x is 1, that's right here, how many do I go up? 1, 2, 3, 4. I go up 4. And the last one, when x equals 2, how many do I go up? 1, 2, 3, 4, 5, 6. Bam, there you go. If you look at this, it looks like every time x increases by 1, y is increasing by 2. So that would be the rate of change, a +2. All right. Good luck on the mastery check. Good luck finishing this packet. Durkis out. I don't know how this keeps on happening, but all these videos of me on YouTube just keep on popping up. Here, look at this one.